started for the second one. First, thank you very much for coming here instead of enjoying the nice weather. Our next speaker is one of the reasons why we all part of the MLOps community, which, by the way, if you're not part of the Slack channel or you don't follow the blog or the YouTube channel, or please join, because there's a lot of awesome content. So Luke, our next presenter, was one of the founders of the community and our local hero from Bristol. So big round of applause for
Awesome. Cool. Hi, everyone. It's amazing to do a meetup talk in person again for like the first time in 2 years. So thank you for putting this on. I'm going to talk about DevOps, security, and observability in ML, and talk about how you can piece together a stack from what I call the MLOps jungle. And as soon as I said MLOps jungle, Kai insisted that I do this. So this is all Kai's fault. We're only just going to have a few seconds of that, but he said, just make it come out the speaker of the laptop, doesn't matter. So yeah, now that we're warmed up, I want to talk about integrations, because there's this like totally mental landscape of, and I don't expect you to be able to see all the things on this slide. The point is that you can't really see all the things, but there's this kind of totally mental landscape of different tools available for MLOps these days, and this is even from the beginning of last year, so it will have expanded since then. But this conversation came up on the MLOps community Slack. I think it was today, actually. So Laszlo, where's Laszlo? There he is. Laszlo started this thread on, I can't remember what channel this was on, maybe it was on general, I don't know. But he said, is there a collection of MLOps tools, their capabilities, and how they integrate with each other? And then Dan Jeffries, who's working at the AI Infrastructure Alliance, is putting together this massive report of all of the different tools and so on. And he said, well, we've written this massive report on all the different tools, but we haven't even started to cover integrations because it would be this monumental effort to see how all these different tools work together. And I even highlighted this. He said, it's probably impossible, I would say. So I wanted to suggest that we try to attempt the impossible and look at actually how can you integrate some of these tools together. And I'm not going to try and integrate every tool with every other tool, because that's obviously like, that would be impossible. That would be actually impossible. It would be a combinatorial explosion. That's the word I'm looking for. But what we can do is look at patterns in how you can integrate these tools together when you plug them into each other. And so I'm going to go through a few patterns and then look at some examples. But first, I wanted to just quickly talk about what the ML process or the MLOps process is. This is probably kind of basic stuff for everyone here. But just quickly, the idea is that you have some data and you use some code to convert the data and the code into a model. You then deploy that model somewhere so that it's connected to an app, so that it's actually delivering business value, so it's making predictions in production. And then you monitor that model, and then you feed the results of that monitoring back into this kind of iterative process of tweaking the data, removing bias from the data, changing the code, trying new model architectures, deploying them in different ways to improve performance and things like that. All the time in the effort of towards improving business value for the applications that are consuming those models, whatever that is, whether they're API endpoints that are running in the cloud, or I was talking to someone today who deploys models onto iPhones for sporting events. So like there's this wide variety of what deployment means. But the point I want to make is that you're following this process even if you have no process. So even if you're just doing really ad hoc, like basic stuff on your laptop, or there's a few of you and you're just like SSHing into EC2 VMs and doing stuff, you're still going through this process. And then you're just doing it with ad hoc tooling, with an ad hoc approach. And then underneath these processes, you can kind of swap in and out these different stacks. And of course, there's a whole nother talk on data stacks that I'm not going to give today, like looking at dbt and all of that world of Snowflake and all interesting things that are happening there. But But what I want to focus on is the MLOps stacks, which is how you get from the data to the models. And of course, that stuff runs on top of infrastructure. It's all programs running on computers somewhere. And so the infrastructure might be clusters, Kubernetes, for example, storage, S3, for example, Git, and Gitops, which I'll talk about in a minute. Who here is familiar with the term Gitops, by the way? Cool, OK, that's good. About half the room. And then there's auth, which is another important component that you need to tie these things together. So I'm going to talk a bit about how you can tie things together with auth. So I'm going to kind of start at the bottom and work up this diagram. So first, yeah, I'll just cover Kubernetes and Gitops quickly. So this is a picture of a Kubernetes cluster. You can basically ignore the picture. I just put it up so I can talk about Kubernetes. Kubernetes is an interesting... so who here uses Kubernetes in their day-to-day work? OK, that's interesting. Also, quite a lot of people. So Kubernetes has become almost a standard way that people deploy software. It's not the only way, but it's become kind of the big winner in that space. And obviously, it came out of Google, and that's the whole history. But the reason that Kubernetes is interesting from an integration perspective is that if you have tools, MLOps tools, some of them will be deployed on cloud services, right? Or they're consumed as services, and then you don't have to worry about where you're deploying them. But many of them do need to be deployed somewhere, and they often depend on Kubernetes. And actually, the fact that there is this common layer that there didn't used to be for how you deploy software means that it's easier to integrate tools together when they are all deployed to the same Kubernetes cluster. Because, for example, they can name each other reliably. You can have DNS inside the cluster, so you can say service.namespace, and you can talk to something else. Whereas in the old days of like enterprise software on physical servers, that would have been much less consistent from one integration to another. And yeah, so there's this basic idea of if you've got a cluster and you can throw lots of different stuff on it, then that's going to help you integrate that stuff. That's one step towards it, is just deploy it all onto the same cluster to begin with. I also want to talk about GitOps. So GitOps, and this diagram is from a company called Weaveworks that invented the term GitOps, and GitOps is now widely used. My former employer, by the way, full disclosure. But yeah, the idea with GitOps is just that the state of what's running in your production system should be described as a set of manifests that's stored in version control. And if your entire cluster exploded tomorrow, you should be able to recreate it from scratch, modulo secrets, which you might need to do something a little bit more complicated with, but you should be able to recreate it from, and state, of course, that's a whole other conversation. But you should be able to recreate the Kubernetes cluster from scratch. And this is kind of also a specialization of the idea of infrastructure as code, which is embodied in tools like Terraform, where you should be able to version control your entire infrastructure, and you should be able to stand it up in a consistent way. And this idea of applying operations to Git, which has typically been like the world of the developer, is super powerful because it means that you could do things like pull requests for scaling up your API server or whatever you need to do, and you can use kind of these developer native tools for doing operations. I also wanted to call out, so Weaveworks has a product called Flux. There's also an open source project called Argo CD that I'm going to demo in a bit as part of the demo at the end here. And Argo CD is quite nice. It does a pretty good job of actually realizing this vision of I'm going to put a bunch of YAMLs and Helm charts and customize gunk and loads of other crap in Git, and good luck, Argo CD has to reconcile the cluster, which turns out is quite hard, actually. There's lots of scary edge cases, but Argo CD does a pretty good job of putting a nice UI and a nice process over the top of that kind of challenge of keeping the cluster state reconciled with the Git repo. So yeah, just to take a step back on the pattern that I'm talking about here, this is a pattern of using Kubernetes and GitOps. And the idea is that from an infrastructure level, you might put together a system that looks a little bit like this. You've got a Kubernetes cluster. You're using that Kubernetes cluster for model training, as in if you need to train a model with a GPU, then you'll throw it at some job scheduler that's running on the Kubernetes cluster. It will train that model and hopefully record that training to your model management system, but experiment tracking system, but we'll come back to that later. But then that same model and that model artifact will then get pushed back to S3. The training data that the model was being trained on may well come from S3, and then you're also deploying the models that are running in production, assuming you're hosting your models in the cloud, also on a Kubernetes cluster. Maybe the same cluster, maybe a different cluster. People have different tastes, but that's the general idea. And there are a few other dependencies here, like you need a Git repo if you're going to do GitOps. And most people use GitHub, to be honest. A lot of people use GitLab as well. There's a variety of different version control systems. But what should you put in your version control system? You should put your training code, but also your Kubernetes YAMLs for your tooling, like whatever you're using to do the model training and whatever you're using to do the model serving, kind of the infrastructure level stuff for standing up Jupyter, or if you're using Jupyter, or Kserve if you're running your models in production on Kserve. But then you should also GitOps your models, which is kind of like a level on top. It's the artifact that's produced by this process, and they should also be GitOpsed, ideally. And then, of course, there's also, just to, kind of for completeness, there's a dependency on a container registry. You might use Docker Hub or ECR or whatever. And what would you put there? Well, you'd put kind of snapshots of your training environments, Jupyter and all the dependencies or whatever you're using for training, and the Docker images for your inference servers. If you've customized your inference servers, you might also just use stock kind of Kserve container images and reference the model artifacts in S3 for that. But that's kind of, from an infrastructure perspective, all you need to do a basic MLOps stack. And you can go loads more complicated than that. But so I'll talk a little bit about security next, and in particular, I'm going to talk about OIDC, which is something I've learned about somewhat recently. I kind of went down this security rabbit hole because turns out it's quite easy to throw a bunch of stuff on some clusters like MLflow and Kubeflow and wire them up, like set the right environment variables for your MLflow tracking server in your Jupyter notebook. It's not actually that easy. It's kind of complicated with Kubeflow, but you can wire it up in the right way so that like so Kubeflow can talk to MLflow. But then how do you connect that to your users? And how do you enable collaboration between users? And how do you secure that? In particular, how do you secure the MLflow instance? Because MLflow out of the box doesn't give you any kind of like login or integration with anything. So I started looking at how you can kind of stand up these things, get them talking to each other, but it's not really useful to an organization that has like more than maybe just like a tiny number of people working on something, to not have any isolation between these components. And so, yeah, I mean, OIDC is like the industry standard way of doing this. And it's just basically this idea that there's an authorization server, which is sometimes called an IDP, identity provider, and a user shows up, talks to the authorization server. Maybe they talk to the authorization server, which defers them off to like Google to do an OAuth loop to connect with Google or whatever else, GitHub or LDAP, Federation. And then the authorization server gives back the user and the client application. They basically do this token exchange thing where the user gets a short-lived token and I think also a refresh token so that they can refresh that credential. And yeah, I mean, this is kind of like, has become the industry standard way that applications get connected to each other from an auth N and auth Z perspective. And a very popular one of these things is called Keycloak. And when I started looking at Keycloak, I was initially put off by it because it was written in Java. But I persisted, and actually Keycloak is very powerful. It gives you, the ability to, I just blatantly stole this slide from someone else's presentation, but it gives you the ability to do like user federation with a bunch of different providers. It has a very sophisticated RBAC and also other flavors of things that I can't even remember, like RBAC. You can specify authorization rules as JavaScript snippets if you want to. You can basically go like arbitrarily complex with the way that you can set up who has access to what. And it has a very powerful language for describing that. It's also a little bit kind of impenetrable, to be honest. The documentation is very, very lengthy. The UI feels like it's from the 90s, and there's an awful lot of clicking involved. But Red Hat, who own the project, are working on it, and they're making it better. And there's a bunch of competing projects that have been written in Go that try and do some of the stuff that Keycloak does, but none of them seem to be nearly as mature as Keycloak. So I would say bite the bullet and deploy a JVM in your Kubernetes cluster. How bad can it be? So yeah, I mean that's the Keycloak piece. And the other piece is that there's tons of tools that integrate with OIDC. Like I said, everything except MLflow basically integrates with OIDC. So you can integrate Argo CD with OIDC, and then you can log into Argo CD using your Keycloak single sign-on token that you got when you logged into Pachyderm, like yesterday or whatever. And so you can configure Argo CD with an OIDC provider. You can configure Jupyter Hub with an OIDC provider so that you can have a team of people provisioning Jupyter instances that may or may not have GPUs, that have like bigger or smaller machines, depending on what kind of workload they need. And Jupyter Hub is also nice because it automatically shuts down your containers when you're not using them. And then if you have that in an auto-scaling cluster, then the cluster will automatically shut down resources when the users are idle, which solves the AWS build problem, which is especially painful with GPUs when you're doing training. And then Grafana, which you'll probably end up using for monitoring, also supports OIDC. So does Kubeflow, although as usual with Kubeflow, it's complicated. And then Pachyderm does as well. So it's like, hey, I've got loads of good tools that I can plug together that all talk the same auth language. And so I can imagine building a stack that uses Keycloak as a way to kind of centralize where the organization expresses who can access what, and also supports integrating with their crappy Active Directory server that they have to integrate with, and also gives you access to all of the tools that you actually want to use. So this is kind of the pattern that we've seen coming together from an auth perspective. So I've got 12 minutes left. Another thing that I recommend doing, another pattern that I've found helpful, at least for the projects that I've been working on, are that you define and agree with the people you're working with on an ontology. So what is an ontology? It's the branch of metaphysics dealing with the nature of being. Sorry, wrong definition. It's a set of concepts. That is actually another meaning of the word ontology. It is the set of concepts and categories in a subject area or domain that shows their properties and the relationships between them. It's just a fancy way of saying, like, oh, name what the things are, like answer the question, what is there, and then answer the question, how do those things relate to each other? Because there's an awful lot of tools in the space, and it helps to group them. And so, for example, our ontology that we're using is that there's a thing called a cluster provisioner, which is how you get a Kubernetes cluster. There's a thing called a cluster target, which is a Kubernetes cluster that exists. There's a thing called a project, which holds a collection of other things within it that are related to the same business problem, or something like that. There's a notebook server launcher, which is like a Jupyter Hub or a Kubeflow notebooks server. Experiment trackers and model management servers. Maybe you could tease those out into two separate categories, but MLflow is in that category. Our generous hosts, neptune.ai, are in that category as well. And then, of course, there's the models themselves, which are the artifacts that you're building. And then you can have a whole discussion about, is the model the weights file, or is it the built container image that has the weights file in it? How do you make sure that you're running the same version of the code? That's a conversation you need to have. Then you've got GitOps servers, which are things like Argo CD or Flux, which reconcile version-controlled infrastructure as code with the real world, with clusters or with a cloud provider. Then you've got Git servers. That one's pretty obvious, like GitHub or GitLab. Data sets, whatever that means to you. Maybe it's an S3 bucket. Maybe it's a Pachyderm repo. Maybe it's a Snowflake table or an SQL connection. And then container registries, again, is pretty straightforward. So yeah, just have a conversation about what these things are and define them. I think as an industry, we're quite bad at having consistent naming around these things, and it makes knowing what a tool does even harder because everyone uses different language. And all the security stuff uses different words for things as well, which is annoying. But anyway, you must be thinking, tell me about the stacks. And when I said to myself, tell me about the stacks earlier, I just heard this in my head. I don't know why, but I wanted to put that in there. So anyway, here's a possible stack, right? I'm just going to put this out there as one possible stack that you could build. And in the middle, you've got all the glue code that you need to write to glue these things together. Or maybe it's glue YAMLs or something. But yeah, you might use Keycloak for teams, projects, collaboration, like defining who can access what, and also, to some extent, like what groupings of things there are. You could put projects into Keycloak. You've got notebooks. I'll go this way around. Anti-clockwise, you've got notebooks, of course. Who likes notebooks? OK. About half the room. That's cool. I mean, that makes sense. You can also have like hosted VS Code in this box if you want. Or like PyCharm with a server in the cloud that you can SSH into from your PyCharm instance that you're running on your desktop, or something like that. But often when doing ML, it's useful to have access to these GPU resources, but only when you really need them, rather than having one sat on your desk all the time. So that's why having cloud-hosted development environments is more useful. Then there's data and pipelines. I personally am quite a big fan of Pachyderm. I think it does a nice job of keeping track of versioning and lineage of everything. So check that out if you're not aware of it. And then for experiment, but there are obviously other things you could put in that bucket, like you could put Airflow plus DVC to do that data versioning plus pipelining, or you could put Kubeflow pipelines in there, although none of those other pipelining solutions are data-driven, so it depends on your needs. And then experiment and model management. I put MLflow in that box because it's readily available, but then you could put lots of other tools in there, like Neptune or Comet ML, or there's a bunch of other ones. Even Kubeflow has a built-in metadata server, although it's not very good, in my opinion. There's a theme here. And then, yeah, like building models, deploying them. Kserve is quite popular there. So I won't hate on Kubeflow too much because Kserve is part of Kubeflow, or at least it came out of Kubeflow. And we use that for actually running models in production. And then there's a whole section on statistical monitoring, which might be interesting, but it's also probably another talk, so I might skip over it. But the idea was, I'll go over it quite quickly, but the idea with statistical monitoring is that, well, I'll get onto it in a second, which is now. So the idea with statistical monitoring of models is that observing models is different to observing software, because when you're observing software, like a microservice that's running in production, you can look at latencies and error rates on that and get a pretty good idea of how it's behaving. But with a machine learning model, because it's operating on dynamically changing data, the model can start going haywire for reasons that are not visible to you if you're just looking at latencies and error rates. So for example, the input data might vary significantly in production from the input data that the model was trained on. You might have a self-driving car that was trained only on pictures of road signs in sunshine, and then when it snows, suddenly it can't see stop signs anymore for some stupid reason because it was looking at the edges of the stop signs or something. So there's data drift, and then there's model drift, which is how the classifications, the distribution of classifications that the model is making, how are they changing over time? And if you see one of those things change significantly, then you might need to step in and do something. So this is from another project that I worked on called BoxKite, which is open source. But the point about this instrumentation thing is that you have to do it throughout the lifecycle. So you have to start your instrumentation at training time, and then you have to compare the instrumentation that you've run at training time with what you're seeing in production. So what you can do, for example, is you can record a histogram of what your input data looks like, and then compare that to a histogram of what input data the model is seeing in production. And then you can plot a KL divergence chart in Grafana that shows you how those numbers are changing over time. And you can do the same thing for models with continuous inputs and outputs, as well as discrete inputs and outputs with a KS test. I'm not a statistician, so that's as much as I know about that stuff. But the thing that the team I worked with on this did that was cool was that they implemented the formula for calculating KL divergence in PromQL. So it could be calculated live at runtime, which was pretty cool. So that's all on GitHub and freely available. And yeah, so when you're doing that, you have to keep track of the model and the training time histogram, and then compare the training time histogram to the runtime stuff at runtime. So yeah, there's that whole kind of statistical monitoring piece that is nice. So I've got 3 minutes left. I'll probably go a few minutes over, but please pray to the demo gods for me, because I wanted to show you something that I've been working on, which is brand new, and only started working this morning. Yeah, I've been talking about like a bunch of these different pieces, and we're putting together a project to try and make it easier to deploy them all and put them all together. So what you can do is, we've got this getting started guide online. You can log into an account. The interesting thing about the accounts is that each account on the outer system gives you a completely separate Keycloak tenant. So a tenant in Keycloak is an isolated kind of slice of the world. And so within that Keycloak tenant, I think I can actually show you. Oh, there it is, yeah. Within that Keycloak tenant, you can plug that into your own company's like SAML v2 provider or whatever you need to do, or connect it to, and you can do user and group management and do all the complicated stuff you could do inside Keycloak from that separate tenant. But then you can also connect into this thing that we're making called Helix. And at the moment, Helix just deploys Jupyter and MLflow and Kserve. And so what you can do is, basically you can connect it to a Kubernetes cluster. You can connect it to a Kubernetes cluster you've already got, or you can provision a cluster from this service we run called TestFaster, which is actually running on a bunch of servers in my basement. So blame me if it goes down. But yeah, it's you can click a button, get a Kubernetes cluster that's pre-configured with a bunch of stuff. You can connect it to a Git repo. In this case, I've connected it to this one on GitHub, which is here. And that's empty at the moment, but we'll go back and look at that in a second because it does the GitOps thing I was talking about. And then it's also connected to an Argo CD installation, and it uses that Argo CD installation to reconcile things that are in the Git repo against the cluster. And then it's also connected to an object storage bucket, in this case, an S3 bucket that's my own. And then you can also connect it to a container registry, although you don't have to at the moment. And what you can do with it is you can open up Jupyter, and that should open over my phone's tethering. And then you can train a model and register it and connect and log the model to MLflow. So we've automatically hooked that up to the MLflow model. And I've named this model -cookpad. And then if you go in here and look at the models, then you can see all the models that are in MLflow. You can find the cookpad one, hit deploy on that. And then it creates a Kserve deployment, which is that Kubeflow piece that I mentioned. And what it's doing under the hood is, or under the bonnet, I should say, is it's written that model to Git as an inference service that can be deployed, that's deployed there. And it's pointing to that specific S3 bucket with a specific, with that name -cookpad. And then it's also come up with a URL for that model. And so if we follow the documentation, I find it's always a good idea to follow the docs. If we follow the documentation, then we can send a request to that model. It's that one. And then it's a diabetes model, so it'll tell me whether I've got diabetes or not. Although I don't know how to interpret the output, so that's good. And yeah, it worked. So we just trained a model in Jupyter, deployed it to Kserve via MLflow, and yeah, it's kind of early days with this project, but I'm trying to take like a bunch of the learnings that we had from these principles and make it useful to people in general. So this bit is the ask for help at the end. Like we're looking for beta testers if people would like to get involved and tell me what to build, tell me what not to build. Then yeah, please just get your phone out and drop me a one-line email, or drop us a one-line email. And yeah, I hope this was helpful. Thanks very much.